Yes, we can see your slides. Yes, just to make it full screen. On the right side bottom near the zoom, the full screen option is there. On the right side bottom, yes, that one. Yes, full. Yes, now it is fully visible. Can you able to listen us? Dr. Annapurna, you are muted. Please unmute yourself. Please unmute yourself. On the WebEx, on the WebEx. On the WebEx, you can unmute yourself. On the WebEx screen.
Hello.
Yes.
Am I audible?
Yes, now you are audible. You can share the screen. Yes. Now your video and audio both are perfect. Please share the screen.
Is it visible?
Yes, yes, it is visible. And just make it full screen. Dear participants, it is my pleasure to welcome Dr. Annapurna Panda from Center of Data Science, Institute of Technical Education and Research, Shiksha Anusandhan Deemed University. Dr. Annapurna Panda has completed her PhD from Indian Institute of Technology, Bhubaneswar, and her postdoctoral research work from from Department of
Design Department.
Department of Engineering Design, IIT Madras, and she has expertise in the field of nature-inspired optimization algorithms, and she has designed various new types of nature-inspired algorithms, which is inspired from various phenomena like the colliding bodies and symbiotic organism cells. She has also applied it to solve various mathematical problems. So over to you, ma'am, for the session.
Thank you, sir. Thank you to invite me in this FDP program. Today, I am Dr. Annapurna Panda. I am going to give the talk on nature-inspired algorithm, colliding body optimization and symbiotic organism search. Actually, nowadays, this is very interesting topic is nature-inspired optimization algorithm, and various new optimization algorithms are developed nowadays. In 2014, Kave and Madhavi developed colliding body optimization algorithm from the physical concept, physical phenomenon. This is a physical inspired optimization algorithm, and it's based on the collision of two bodies. When two bodies collide with each other, then their velocity will change with lots of kinetic energy, and that concept is used to develop this optimization algorithm. And this optimization algorithm is a parameter free algorithm, so it is very comfortable to use for many mathematical problems. And here this optimization algorithm, nature inspired optimization algorithm, consists simple equations which given by velocity and position updation. We have to update the velocity and we have to update the position. So computational complexity is very low here. So this is the concept. Suppose two bodies are there having mass m1 and m2. One body is moving and another body is with velocity 0. That means the stationary body. The body which is moving with a velocity, when collide with the body which has a velocity 0, then after the collision, the both bodies change their velocities. The moving body, the velocity of the moving body decreases, and the velocity of the stationary body, which is earlier 0, it will increases. So the both velocity changes, and the both velocity change the position of the body, and it is accordingly it's going towards the global optimal solution. So here two bodies are there with mass m1 and mass m2 and velocity v1 and velocity v2, where the stationary body has velocity 0. When they both are colliding each other, then from that position they have changed the velocity v1 dash and v2 dash. So v1 and v1 dash and v2, some kinetic energy, conservation of some kinetic energy is there, q. So v1 dash and v2 dash are the updated velocity, which is calculated by these two equations, that is conservation of momentum and conservation of kinetic energy. By using these two physical equations, we change the new velocity and update the velocity, and ultimately we have to change the position of the bodies. And here we use a coefficient of restriction, that is epsilon, and this coefficient of restriction is known as the elasticity of the bodies. And then you have to update the, after updation of the velocity, we have to update the position of the bodies. Then you have to evaluate the fitness of the colliding bodies. Then we have to calculate the mass again. So here the mass is by this equation, mass is calculated by using the fitness of the bodies and the maximize fitness and the fitness of all the bodies. Then this is the velocity of the stationary body initially, that is vi is equal to 0, and moving bodies we have to give the velocity, that is depending on the position, xi minus k by 2. So then after collision the velocity will change, that this is vi dash and vi double dash. This two velocities we have changed of the stationary body and moving bodies. Then we have changed the position, stationary body and moving body, xi new. We have to change the position. Then we have to calculate the coefficient of distribution, COR, that is epsilon is equal to 1 minus iteration, first iteration by maximum iteration. It is always varies from 0 to 1. The coefficient distribution is always varies from 0 to 1. So we continue this procedure up to, we have to find the good fitness value. So this is the flowchart of the colliding body optimization. So, and we use this problem minimization of f of x1, x2 sin x1 plus cos x2 using colliding body optimization. So first we have to consider the position of the we have to consider four bodies C1, C2, C3, C4. We have to consider the positions x1, x2 for all the bodies. We have to find the fitness value of all the bodies using this equation f of x1 x2 is equal to sin x1 plus cos x2. Using this equation you have to calculate the fitness value. Using the fitness value, you have to calculate 1 by f and then mass of the body, that is 1 by f by sum of 1 by f. Then B1 and B2, first two are the stationary body and second two are the colliding body. So the velocity of the stationary body are 0 and the velocity of the colliding body we have calculated. Then after the collision, these are the updatation of the velocity, and this is the for the first iteration our epsilon is equal to 1 minus 1 by 10. This is the first iteration, and the total number of iteration we are considering here is 10. So 1 minus 1 by 10, that is 0.9. So for first iteration our epsilon is 0.9, and we have calculated the B1 and B2 and B1 dash and B2 dash. Here we update the position. This x1 and x2 are the initial positions, and x1 and x2 are the capital small x1 and small x2 are the initial position, and the next two both are the updated positions. Here we consider the random value in the range -1 to 1. Then this is the CD plot of the function, and this is the counter plot of the function. Then you have to we have to consider 10 colliding bodies and number of iteration 20, and we here find the convergent analysis by PSO, BFO and CPO under these conditions. So here the first line is giving the result by PSO, the second dotted line is giving the result by BFO, and the third line, the clear line, is giving the result by CBO. So clearly we can see that CPO is giving a good result, and we can use this algorithm to solve some optimization problem. Similarly, symbiotic organism search is a nature-inspired optimization algorithm. It is also developed by 2014 by Cheng and Prayago. So in this optimization algorithm is based on the ecosystem. So what is the, depending upon the three phases of the ecosystem, in ecosystem three phases are there. First one is mutualism, parasitism and commensalism. So depending upon these three phases of the ecosystem, we have to, this symbiotic organism search is developed, and here we have to initialize p number of organisms are there with dimension d, and we have to find the fitness value. And we have to find the O best, which organism is best in the environment. Then in mutualism phase, what happens in this phase? Interaction between two organisms happens. That means in this interaction, both organisms are benefited. That means when grass and cow are interact with each other, the cow is find his food from the grass, and grass is developed by itself. So grass and cow both are getting benefited by this phase. So here the both organism is updated by the equation OI new and OJ new. OI and OJ are the first organism, then the updated organism is OI new and OJ new. So here we are using the one factor, that is mutation vector, and two factors, that is BF1 and BF2, that is benefit factor 1 and benefit factor 2. So benefit factor 1 and benefit factor 2 we are taking randomly the values between 1 or 2, or the mutual factor we have calculated by using the two organism OI plus OJ by 2. So here the output of mutualism is MO2PM, that is OI new and OJ new. Next phase is commensalism phase. In commensalism phase, when two organisms interact with each other in ecosystem, then one is benefited and one is unaffected. That means suppose Ramorafish and Sharkfish, when they both are interact with each other, the Ramorafish attacks with the Sharkfish and it collects the food from the Sharkfish. Here the Ramorafish is benefited but the Sharkfish is unaffected. So here only one organism is updated, that is the in commensalism phase from OI and OJ, only OI is updated, and here we use one random value from -1 to 1, and after commensalism phase we get this new set of organisms. Then parasitism phase. In this phase in the ecosystem, when two organisms are interact with each other, then one is benefited and one is affected. Affected means the suppose man and mosquito. When mosquito bites a man, then it the mosquito leaves some virus in the human body. Then the human body create a parasite vector PV, and if the parasite vector, the immunity of the human is high, then the mosquito, the affected by the mosquito is unaffected to the human body. So here only one is affected, but which one is affected? It depends upon the this phase actually. So the weaker organism is affected actually, and the stronger organism is not affected. So that is eliminated. So here, suppose OI and OJ are two organisms in this after this parasitism phase. Suppose OI is the mosquito and OJ is the human being, then it depends upon if the fitness value of OJ is high, then OJ is here, OI is eliminated. If the parasite vector is high, then the OI is here and OJ is eliminated. So after the parasitism phase, we get this new organisms. This is the flowchart of symbiotic optimization algorithm. And here we use one mathematical concept, that is orthogonal array strategies. What happened here? Suppose we have two set of A11, A12, A13 and A22, A22, A23. My xi is this. And after updatation, what we get? Xi new. So I got xi is the initial solution and xi new is the updated solution. If I combine xi and xi new, I can find this vector with n equals to 3 and q is equal to 4. That means 4 variables are there and 3 objects are there. So we get n equals to 3 and q is equal to 4. Xi dash we get this. When we combine, suppose I can combine A11, A12, A13. I also combine A11, A22, A23. I also combine A11, A12 dash, A12 dash. Similarly, if I combine it, I can get 64 number of combinations. But it is too difficult to calculate from the 64 number of combinations which 4 combinations are best or which 5 combinations are best for the next iteration. So for that reason, we have find the orthogonal combination, and from these 64 combinations, I have to find the 16 combination, the best 16 combination by using the orthogonal combination. So this 16 combination is the best combination, and we have to find the fitness value of the 16 combination. How we are finding the 16 combination? A11 is combined with A12 and A13. Then A11 is combined with A22 and A23. Then A11 is combined with A12 dash and A13 dash. Then A11 is combined with A22 dash and A23 dash. When A21 is combined, A21 is combined with A12, but it cannot be combined with A13 because A12, A13 is already combined. So A21 is combined with A12, then again A12 is combined with A23. So my fifth combination is A21, A12 and A23. Similarly, A21 is combined with A22, but A22 cannot be combined with A23. It can be combined with A13 dash. So the next combination is A21, A22, and A13 Similarly, I have to find the 16 best combinations. Then I have used these orthogonal positions here. See this flow chart. After find the fitness value, and we have to go to orthogonal position. We have to calculate the orthogonal position. We have to find the fitness value orthogonal position. Then again we have to find the evaluate the fitness value of all the bodies. Then we have to find which bodies are best bodies to go for the next iteration. Here also in symbiotic organism search, by initialization, we have to find the orthogonal combination and best orthogonal combination. We have to find the fitness value. Then we have to go for the metabolism, communism, and parasitism phases. So now these two optimization algorithm, we have developed the multi-objective version of this two optimization algorithm, and we have solved many multi-objective problems. And here we have basically used this two optimization algorithm to solve mathematical problem. That means differential equation, system of differential equation. So how we can use the suppose two system of differential equations, one system of differential equations are there. We have to convert it into a optimization problem. Then we have to find the parameters using the optimization algorithm. So this is my system of differential equations, and this is the initial condition and boundary value and initial conditions. And then we use the Fourier series equation to convert this system of differential equation into a optimization problem. So this is the approximate solution by using the Fourier series xt and zt. What is xt and zt? So xt and zt are the approximate solution. Xt approximate solution of the system of differential equation, and this is the two equation is giving the approximate solution using the Fourier series. And here you can see A0, AM, BM, and C0, CM, DM. All these parameters we have to optimize using the CBO and SOS. These parameters are called as the coefficient of Fourier series. That means Fourier coefficient. So we have to optimize this Fourier coefficient using the optimization algorithm. The first question is, why are you using the optimization algorithm to solve system of differential equation? Because when the number of optimization, the ordinary differential equation increase, or the order of the ordinary differential equation increase, the previous methods, it fails, or it takes much time to solve this type of differential equation. But when we are doing some project or some modeling, then we have to solve this type of problem. Then we can use optimization algorithm, find the approximate solution. Here we cannot find the exact solution like the mathematical methods. Here we can find the approximate solution of the system of differential equations. So here we consider this electrical circuit, this equation. This is a system of differential equation and very simple problem. dB by dt is equal to 2y minus b, and di by dt equals to minus I minus b. Here the initial conditions are given: I0 is equal to 2 and B0 is equal to 2. These are the initial conditions. By using the Fourier series, we have find the B approximate and I approximate. And here A0, A1, B1, A2, B2, A3, and B3 are the Fourier coefficient. And C0, C1, D1, C2, D2, C3, D3, these are the Fourier coefficient. And we use the CBO and SOS to solve this problem. And these are the approximate voltage and approximate current graph. So here we have plot exact solution, the solution by orthogonal symbiotic search, the result by our orthogonal colliding body optimization, the result by orthogonal PSO, and the result by WCA. And we have compared all the results here. You can see the coefficient we have calculated, A0, A1, B1, A2, B2, A3, B3, and C0, C1, D1, C2, D2, C3, D3. We have calculated all the coefficient by using orthogonal symbiotic organisms are the first column, orthogonal colliding body optimization in the second column, orthogonal PSO in the third column, and the WS water cycle algorithm by the fourth column. So here now we can clearly see that the orthogonal symbiotic organism search and orthogonal colliding body optimizations are giving good results. And this is another problem, that is this XT and ZT represent the amount of iodinic present bloodstream and body tissue respectively. Their response is represented by a system of ODs given by dx by dt is equal to minus 0.09x plus 0.038z and dz by dt equals to 0.066x minus 0.038z. And the initial conditions are x0 equals to 0 and y0 equals to y0. So here x approximate and z approximate are the approximate solution by using the Fourier series. And here A0, A1, B1, A2, B2, A3, B3, A4, B4, A5, B5, and similarly C0, C1, D1, C2, D2, C3, D3, all these are the Fourier coefficient. And we have to find the approximate value of the Fourier coefficient by using the proposed algorithm. So these are the graph by using the by finding the exact solution, then the result finding by orthogonal symbiotic organism search, the orthogonal colliding body optimization, and PSO and WC. And this table is giving all the coefficients we have calculated by using the proposed algorithm. And you can clearly see that OSO is giving good result. This is the second coefficient. We have calculated C0, C1, D1. And here also we can clearly see that orthogonal symbiotic organism search is giving a good result. So in this research, simulation is carried out to determine the solution of the system of ordinary differential equation. In other papers, we are also solved the equations, only linear differential equations using this proposed optimization algorithm. And the Fourier series expansion is employed to do the approximate solution. We have to convert the optimization differential equation to a optimization equations. Then we can use the nature inspire optimization algorithm. We use the Fourier series expansion for that purpose. And simulated result reveals the proposed OSOS algorithm has accurate performance and giving a better result comparison to the other optimization algorithms. Thank you. Any doubt? Any questions regarding the algorithms?
Dr. Annapurna, please on-share the slides.
Okay.
So I request participants to write their questions in the chat box so that Dr. Annapurna will answer them. I hope the chat box is visible to you, ma'am.
Yes, yes.
So participants, you can write your questions on the chat box.
If any query, please write.
In the chat box. There is research scholars. They are sitting over here at MNIT Jaipur location. So they have passed on one query that what are the other mathematical applications on which and these particular optimization algorithms can be.
Yes, actually, we can solve multi-objective optimization problems. The multi-objective version of this two algorithm with orthogonal combination we have already developed, and we can use that two algorithm to solve the multi-objective optimization algorithm. Linear differential equations, we can use this to solve the linear differential equations, non-linear differential equations, partial differential equations. All these type of equations we can use this optimization algorithm solve in mathematical concept. And in application, in engineering application, we can use this one question: how does collating body optimization handle constraints in optimization problems? Actually, uh, collating body optimization, in collating body optimizations, the constant for the constant optimization problem, we have to use the constant handling methods. Like many constant handling methods are there. Normal collating body optimization, we cannot solve the constant optimization problem. We have developed one method that is using augmented Lagrangian multiply method, which is a constant handling method. We use that augmented Lagrangian multiply method with collating body optimization to solve the constant optimization problem. Also, we use the penalty parameters, penalty method with collating body optimization to handle the constraint. I think your query will be solved. Solved. What is your name? What factor influence the collision outcome? Actually, the kinetic energy. The loss of kinetic energy is the main concept of the colliding body optimization algorithm. Any other doubts?
Yes, there is one question.
Sakshi has put, is it clear? The colliding body optimization is depends upon the kinetic energy. When two bodies are collide with each other, the loss of kinetic energy occurs, and depending upon that, that influence the collision outcomes. Yes, sir.
There is one more question. How to integrate the concept of ANN, artificial neural network, in meta-heuristic algorithm? You have recently published an article, Digital Channel Equalizer using functional link neural network trained with quantum Aquila optimizer. So the participant is interested to know about the use of hybridization of the neural network with the optimization technique. So we do have special laboratory sessions in which we will be discussing about the neural network hybridization with various optimization technique, which will be taken care in the thing.
Actually, meta-heuristic optimization algorithm always artificial neural network is always can be used in the meta-heuristic optimization algorithm. So
We will discuss that one in the laboratory session as well. One session earlier in which we have already discussed that how to use it for filter designing, adaptive filter weights, how we can train with the neural network that has been designed. Also the functional link neural network also will be discussed in the laboratory sessions. So as there are no further questions, okay, one more question. Can I use
Can
meta?
you use better?
Hmm.
Yes, you can use meta-heuristic optimization algorithm, nature optimization algorithm for the image processing also. Many work is going on now in image processing area using the meta-heuristic optimization algorithm. You can use it.
Yes, actually, we had a special session in which we have discussed already how these algorithms can be used in hyperspectral image processing. That was already there, and in future also for the upcoming section, there is biomedical image processing application also there in this particular FDP. There is one more question.
This CPU is used to transform real-valued meta-heuristic algorithm into binary coded algorithm.
Actually, both form of the, I think.
Actually, CPU algorithm is a meta-heuristic optimization algorithm, and you can code what algorithm into binary coded algorithm.
It can be coded in binary as well as real domain. I think that is what the form.
We are doing in real valued,
Real.
but I think you can do it in binary coded algorithm.
Uh,
There is no problem.
but actual algorithm is real coded.
Real coded because we are using in mathematical problem and mechanical problem, electrical problem, all type of problems. So we are doing it in real valued optimization, real valued. So you can use in binary coded. There is no problem. You can check it. You can write the code and
So as there are no further questions from the participants, so we thank Professor Annapurna Panda for delivering such a nice session and explaining the participants about two new recently developed meta-heuristic optimization algorithm and their uses in solving the differential equation problem.
thank you, sir. Thank you very much. Actually, nature-inspired optimization algorithm in mathematics to solve the mathematical problem. I will get I am getting a chance to share it with all the faculties. So it's I am very thankful to you to giving me this opportunity. Thank you.
Thank you. So participants, now we have an important announcement from Dr. Ila regarding your quiz today. So the Canvas platform, you have to appear for the quiz that is going to happen today. So Dr. Ila will announce the detail about the quiz.
Hello everyone. I hope you all have got the Canvas link and you have joined in Canvas because as far we can see in a Canvas that Canvas account that among 470 480 people 120 are still pending, means invitation has been sent but they haven't accepted. In the last day I have explained you that how your Canvas link be there in your inbox and how you should log in and how you accept the invitation. Some of the problem has been faced by many people. They wrote us and we are trying to resolve as much as we can. The thing is that this is all the UI when you log in into the Canvas, and you have to check everything, like whenever you have some new credential with some new kind of teaching learning material, you have to explore something. Like in left hand side there will be many sections, like you may be having the modules, you may be having the files, you may be having people. Some wrote me that in people I could not see myself, so that can be seen by the teacher of this particular course. The students cannot see each other how many they are participated, but whatever time you have been given to that canvas tool, that is being recorded. Means every time you log into that course, and the time which is devoted there by you has been mentioned in that, and how many time you have logged in, that is also given there. And when you go to the module section, you can see that day wise all the PDFs, the materials which are being received by the different experts, that is being updated in a day-wise manner. You can find it that in module section. If you can observe, there is a 3 horizontal line in the left side of your Canvas account. So somebody has mailed us that they cannot find that people and module and the quiz section. So just like I told you, this is up to you how you explore the things, because we can help you to log in there and we can help you how to log in that. But something that where you can found the different things, you have to explore somehow. Just like we explore the new thing towards, like in a Gmail you have a different tab for different operations, like you have a inbox, you have a outbox, you have a sent, you have a spam. In a similar fashion, you have to explore something in your course, then only you will be getting the things. And still, if you are getting any problem, you can write to us. And it is very important to appear in the test, because when you appear in this test meaning the quiz, so the after the checking the performance is that quiz, the certificates will be issued. So this is very important to appear in the quiz. And so if you don't find any invitation till now, not log into your Canvas account, do log into Canvas. And if you face any difficulty, write to us. So one practice quiz is floated there. We have announced from day before yesterday that there is a practice quiz. That is just for your experience, how the interface will be look like, how it will be appearing when you will be giving the actual quiz. So the marks, many of you has wrote to us that ma'am, this marks will also be counted, or it is necessary to give this exam or not. This is not necessary, this is just for your experience. That's why I have written that this is a quiz and just for practice test, just for experience. And you have found that very basic simple questions are being asked. So it was just your experience how it would be look like. So, and you also have observed that this test is appeared, or it has floated for long 2 day long, more than 2 days, right? Something is different now, means it is not like that it is just for a particular time, meaning you will be having 1 hour and you have to be completing that quiz in that 1 hour only. No, it is like that we have given extra days. So whenever you have a good bandwidth, good network connection, and whenever you feel that you are ready to give the quiz, so there is a duration of days, like we have given 2 to 3 days for every quiz. So once you log in or once you start your quiz, your time will be started from that. You can watch that timing will also be appearing while giving that quiz that will be given to you. So it is necessary that once you log in and once you opt for a quiz, then you complete it. Okay, but this totally depends then throughout the span of the day, from morning to evening, 1 day, second day, or next day. Whenever you feel like you feel okay, I have read everything, now I am okay, or I will give quiz, then try to appear on that quiz and perform all the questions. Yes, how many questions? I am coming to that point also. So till now, whatever we have studied, we have covered. The schedule is also shared with you. Slides are also shared with you. So very basic questions will be asked. Don't worry about the difficulty level. This is quite easy. If you have thoroughly listened to the lectures, lectures are also available in our YouTube. So you may be answering the questions. I suppose I am predicting that you all will be appearing and scoring the good marks on it. So coming to the question, number of question point. Yes, it will be of 20 questions. It will be of MCQ types. and 30 minutes will be given to you. Means on a go you will be having 30 minutes and you have to complete this 20 questions. And again I'm explaining, you can appear any time of the day, but it will be of 30 minutes duration. And don't worry about it, it will be shuffled. So you may not be taking okay how it will be. This is not your task to think about how the question will be, how it will be floated. You have to just prepare yourself and appear in the quiz. Yes, 20 question, 30 minutes and MCQ. Anything else? How many marks are required for certificate? Till now it is not decided, but depending on the relative grading, then what will be the maximum it would be, then we will decide, and definitely we will share this thing with you. Yes, it will be floated today. It will be showing you in your Canvas account, and it will be started from 7:30 today, and it will be go up to 25th February. So don't worry, 24th to 25th February, and 11:30 p.m. will be the last time. So you will be having 22nd, 23rd, and 24th. This 3.5 days are there, so you can prepare and you can give the quiz. What is the time for today's quiz? It is 7:30. No, time cannot be extended because 20 questions are there and that are being MCQ, so 30 minutes is more than enough. We thought of giving 20 minutes, then we decided, okay, it should be of given 30 minutes. Otherwise, it is of 10 minutes task for you. Don't worry. Any other question? If somebody has not joined to Canvas, I can again explain that PDF to you, how to log in a Canvas. Otherwise, it is fine. The theoretical MCQ, the conceptuals, all the thing, whatever has discussed so far in your slides, in your lectures, that only will be asked. Anything else? So we will be having two quiz. Okay, today we have a quiz 1 and we have our schedule. I think we have shared this schedule with you. So according to that, today is the 21st, the 5th day of our AOT 2025 FDP, and there is a quiz 1, first quiz. And the next quiz will be on next Friday, that is 28 February. And that is followed by feedback and validation session. So after the quiz, you will be having some feedback forms too related to our FDP program. And one more announcement I want to have now, that tomorrow is Saturday and Sunday, and you may find in our schedule there is a 4 session. Means tomorrow and day after tomorrow we will be having 4 session in hand. Means we have a session 4 from 7:30 p.m. to 8:30 p.m.
Have you declared the timing of the first quiz?
Yes, sir, I will declare.
Okay. So we request every participant to actually appear for the quiz, because we have observed that only 200 participants have appeared for the quiz. The thing is that many people are asking how to solve many questions within the time. We have formulated the quiz in such a way that the time allotted to you is sufficient enough. Huge amount of time you will consider when you will answer when you will answer this particular quiz. 30 minutes time is very good enough to answer. And whenever you will start the thing, at that time only after 30 minutes the session will close. So up to Monday night 11:30 you can able to answer the quiz at your suitable time. Today after 7 o'clock o'clock it will be open. So whole Saturday, Sunday, Monday, whatever time you are comfortable, based on your comfortable time, you appear in the Canvas platform for half an hour. Or if you have completed your quiz early, you can submit also early. But once submitted, it is done. That is the thing. So without appearing for the quiz, actually it will be difficult for us to issue certificate, as it is a mandate from the EICT ministry side. So it is again requested to every one of you to appear for the quiz. So quiz 1 and quiz 2, in both quiz everybody must appear.
And one attempt will be given for every quiz. That's why we are announcing that you have enough time, enough days are there. So once you feel okay, then you can proceed with the quiz.
It is a single attempt. Always remember this quiz is for single attempt. Multiple attempts are not there for this quiz.
Yes, quiz is open till Monday.
Yes, we have requested to both Professor Ratnajit and to Professor Kushumdeep also. We will share the slides very soon.
Quiz will be there after your sessions. It will start from 7:30 and you can appear it till Monday. So don't worry, it will be showing.
Today after 7:30 it will start.
We want you here to first listen all the lectures, then you can appear in the quiz. There is no hurry in that.
Yes, and all the video recordings are also available in the YouTube channel.